Let's discuss about timers. A timer is a specialized type of clock and it is used to control the sequence of an event or process. Well, as it is seen that 8051 is equipped with two timers. The three general functions of timers are: the number one is keeping time or calculating the amount of time between events. Second is to count the events, and the third is to generate the baud rates. Timer can be used as a timer or a counter. When it is used as a timer, then the crystal oscillator frequency it receives is internally divided by 12, and which is fed to the timer. The frequency of crystal is generally 11.0592 MHz. After dividing it by 12, the timer receives a frequency of 921.6 kHz. It can be used as a counter as well, where timer 0 and timer 1 can be separately used. The special function registers relating to the timer are TH0, TL0, TH1 and TL1, where the TH0 and TL0 are associated with timer 0, while TH1 and TL1 are meant for timer 1. The TCON and TMOD are the control registers. Let's discuss about the TMOD control register now. The lower nibbles are used for timer 0, while the upper nibbles are used for timer 1. The M0 and M1 bits are used to select the mode in which timer is to be used. The C by T bit is used to select whether it is to be used as a counter or a timer. When its value is 0, it is used in timer mode and it counts the internal pulses. When its value is 1, then it is used as a counter and it counts the clock inputs at pins T0 and T1. The next is the gate bit. When the value of gate bit is 0, then the timer is completely controlled by the instructions, while when its value is 1, then the timer will be controlled by the interrupt and the instructions as well. The other control register is the TCON register, whose lower nibbles are related to the interrupts, while the higher nibbles are related to the timers. Let's discuss about the higher nibbles first. The TF1 bit is set to 1 when the overflow occurs. The TR1 bit is used to start or stop the timer. Its value must be 1 if it is to be used. The other bits are meant for external interrupts, where IT1 is the external interrupt level type flag, while IE1 is the external interrupt H type flag. Let's discuss about the timer modes. The first one is mode 0, that is 13-bit timer mode. In this mode, the 8 of the lower bits and 5 of the higher bits are used for counting. Its maximum value for counting is 1 FFFH. When the overflow condition occurs, then the timer overflow flag is set and the interrupt is generated. The mode 1 is similar to the mode 0, but in this the all 16 bits are used for counting, hence the maximum value for counting is FFFH, and when the overflow condition occurs, then the interrupt will be generated. The next is the auto reload mode, that is mode 2. In this mode, the lower 8 bits are used for counting, while the higher bits are used to store an initial value. When the overflow condition occurs, the lower bits are automatically reloaded with the value of the higher bit, hence the overflow flag will be generated and the interrupt will be caused. Let's come to the mode 3. It is used when we need to use 3 timers simultaneously. In this case, the timer 0 is split into 2 8-bit timers. Now the lower bits will serve as the timer 0, its higher bit will serve as timer 1. This will be the 8-bit timers, while the timer 1 can be separately used as a 16-bit timer. When the overflow condition will occur, then the timer overflow flag will be set and an interrupt will be generated. After the interrupt will be generated, the program execution will shift to the interrupt service routine, and after serving that, it will return to the original program.